Okay, so today I'm going to be introducing you to two really important pieces of equipment. The first piece is a type of electronics equipment called a breadboard, okay? And its purpose is just for building basic circuits. Okay, so here's an image of a breadboard, okay, like what it would look like up front. And this is a piece of one that's been taken apart. Okay, and essentially what it is it's just a series of rails, okay, like these rails here, and then two long rails on each side. And what it does is anything that you put in any of these holes along the same rail is connected, anything you put along this long rail is connected, anything you put along this long rail is connected. So what's typically done with a breadboard is you would put the positive end of your power supply here, your negative end of the power supply here, and anything you wanted to connect to the positive power supply you put on this side, anything you wanted to connect to the negative power supply you put on this side. Okay, and with this small piece of equipment you can actually build some very complex circuits. Okay, we'll get to that a little bit later. We're going to pair this piece of equipment with another tool that's called a microcontroller. Okay, so this is a microcontroller. It's a specific one called the Arduino. Alright, and basically using a computer you can write code that you will send to this board, a set of instructions, and it will basically control electronics. Okay, along the sides here and here we have a series of pins, okay, and they're all numbered. Okay, so for example, this is pin 7, this is pin 0. The one that will be most important to us today is where the power supply comes from. Okay, the 5-volt pin is where we power things from. Okay, and the ground pin is where the negative side goes back to. Now, before we get started, these tools, or these microcontrollers, are really cool. We can do a lot of stuff with them, okay, but they can be broken. Okay, it's not very difficult to permanently damage one of them. Fortunately, they're fairly low cost compared to the typical microcontroller. Okay, if you enjoy what we are going to do the rest of the semester in class, you can get one of these with a kit of parts to go with it for about $20. Okay, so what's important though is this. If you were to take this pin right here and take a wire and connect it to one of these pins, you could damage the board forever. Okay, so you have to be really careful about that. Now, another way you could do that, and this is the way that you probably potentially could do on accident, if you're using the breadboard and you have one end connected to positive and one to negative, if you were to accidentally connect both of these ends together, that would kill the Arduino. Okay, and it could permanently damage it. Okay, so you have to be very careful about that. Now, the point in me telling you all this is because it's something you need to know so we can protect the equipment. But if you're being careful, there's no reason that you would do anything to damage it. Okay, as long as you're following the instructions and being very careful with what you're doing. Okay, when the Arduino is plugged in, you're going to see these lights turn on. Okay, and they'll be blinking and stuff like that. And maybe you'll see this light on right here. If, as you're building a circuit, if you see any of these lights dim, unplug the Arduino. Okay, you'll protect the Arduino board as well as the computer, and that's just the safety tip that we're going to have to protect any of these things from getting damaged. If we see the lights start to dim, we unplug it. Okay, the same thing if you start to see smoke come out of something, unplug it. Okay, that's the way that we can avoid some different things happening. Okay, so I'm going to show you how to build a basic circuit with the Arduino. Okay, so now I'm going to show you how to build just a really basic circuit here with the Arduino. You can see there's a light blinking right here. It might be hard to tell, but there's a green light turned on here. This is the breadboard. It kind of gets washed out in the light, but this is what it looks like. Okay, we have some resistors right here. We have some LEDs right here. And then these are tools right here called jumper wires. So what I'm going to do is I'm going to create a circuit that lights up one LED. Okay, so now LEDs cannot handle very much current without burning out. And this can supply enough current to burn out an LED. So to protect them, we put them in series with a resistor. This is a low-level resistor that will allow us to protect the LED. So a couple things to remember. the LED has a positive leg and a negative leg. We need to connect the positive leg to the positive end of the battery. So what I'm going to do is this. I'm going to take it and then put it, basically I'm just going to pick a random spot for it on here, have it in two different rows, okay, like this. Alright, you can see it sticking out. What I don't want to do is put it like this. Okay, the reason why is, if you look at the, if you saw in the other part of the video where I had the cross section of one of these breadboards, those two legs right now are connected together because they're in the same row, and so no current will go through this LED. They have to be in different rows so that it forces the current to go through both legs. Okay, then from where I connected the negative leg, I'm going to put a resistor in that same row so they're connected together, and then I'm going to put it in just a random row right here. Okay, now I'm going to take a wire to connect where I have the positive leg. Okay, right here, I'm going to stick it in that row. Okay, I'm going to put it in the positive row right here on the breadboard, so we'll call that like our power rail, so in the power rail. And then I'm going to take the other end where I have the resistor connected and put that into the ground rail. Okay, like this. Alright, so here's the circuit I have built. Now I'm going to power it from the Arduino. So I'm going to plug one wire into the pin that reads 5 volts. Okay, and I'm going to put it in the power rail right here. And you might have to push a little bit to get in. And I'm going to connect the next one, the ground one. Okay, so it's plugged in there. I'm going to connect it to the ground rail right here. Okay, and I don't know if you can see, I'll turn it like this. That makes the LED light up. Okay, so you can see the LED is turned on right now. So the first thing you're going to do is you're going to get your LED to power up. Once you've done that, your next assignment will be to power up 2 more LEDs at the same time. Okay, and as we're doing so, we can get a little bit creative in that we can save ourselves a bunch of wires, because, for example, when this wire is plugged into here and then connected to the LED, I can shorten that by just plugging the LED straight into the power rail, and then I can have the resistor go straight into the negative rail. Okay, and I can do that for every single one of the LEDs. Okay, so this is an example of a basic circuit. One thing I can do is, if instead of plugging it in to this power rail right here, I can instead take the power rail, remove it, okay, and plug it into a pin. Now while I'm doing this, I'm going to unplug the power so I don't accidentally short anything out. I'm going to plug this into one of the pins along here. Okay, let's plug it into pin 13. Okay, yeah, it's in pin 13. Okay, from there I'm going to create a set of code that's going to basically cause this to blink. Okay, so let's go ahead and turn to the computer screen where I'll be writing the code. So now I'm logged into CodeBender. What I can do here is I can create a new program where I click Create Sketch, or I can click here where it says Examples and Libraries. I'm going to click that, and it's going to bring up a bunch of sample codes that I can load onto the Arduino. Okay, we're going to click the Basics one, and we're going to choose the one that says Blink. So under Basics, it brings up Examples. We want Blink. Okay, when you do, alright, we get a series of code right here. Okay, and here's how it works. All of this green code right here is code that can be edited, or that doesn't affect. All this green writing here is notes for the person reading the code or writing the code. It doesn't have anything to do with, or it doesn't affect the code at all. So you can write whatever you want to say on it, okay, and it won't affect the code. The lines that are not green do affect the code. So here's what happens. The first line, it says int LED equals 13. What's doing right here is it's creating a variable called LED. So just like we have variables in algebra, computers have variables too. And this variable stores the number 13. Okay, so that means every time the word LED is written, you see it here, here, and here, it's referencing the number 13. Now the reason this is useful is because we can easily change that number right here, and we don't have to go through and change it every time it appears in the code. Later we'll also do math with variables, and so it allows us to do math without having to do the calculations individually. Okay, and so it's a sign at the end of every line we have to put a semicolon to let the computer know we're starting another line of code. So we start by creating this variable, then we get to this, what we're going to call a function called the setup function. Okay, don't worry about the word void for now, we'll talk about what that means later. But what the setup function does is it tells the Arduino that the pin 13, which has the LED on it, is going to be set as an output. What that means is we're telling the Arduino we're going to control something with that pin. Okay, so when the Arduino turns on, it goes through the setup loop one time, and then it goes to this function called loop and runs this over and over and over again, infinite numbers of times. Okay, and so here's what it says. It says take pin 13, which we had stored in LED, take pin 13 and turn it on. When we write the word high, that means on. When we write low, it means off. Okay, it's saying turn it on. It's saying delay. What this tells us to is delay a certain number of milliseconds. It says 1,000 because 1,000 milliseconds is 1 second. So it's going to turn it on, wait for a second, turn it off, wait for a second. And since it's the loop, it just keeps doing it over and over and over again until you power it off. Okay, so we'll take this code. I've plugged in the LED to pin 13. Okay, I'm going to put the power rails back into the Arduino. Alright, you can see, let me unhide this screen for you so you can see it in the bottom. Okay, or in the top there. I'm going to plug the power rails back in. Actually, let me upload the code first. Okay, so I don't have the Arduino plugged into this computer yet, so let me go ahead and plug it in now. Okay, so I've got the Arduino plugged into my computer now. You can see the light blinking that it's on there. I'm going to come down here. I'm going to click Run on Arduino. And now this code is going to be written to the Arduino. Okay, it says upload is successful. Now you can look over here. I'm going to plug in the positive and negative. So I had red to the positive. Okay, black to the, or the orange to the negative. Before I do, this is a loop here running from pin 13 into the bulb, through the resistor, and then back to the ground. Okay, and so what's happening here is that this pin 13, you could hopefully see it blinking, is turning on and off. So it's switching between 5 volts and 0 volts over and over. Okay, when it's at 5 volts it lights up, when it's at 0 volts it turns off. Okay, we can see at whenever it's turning on, we're seeing LED high, delay 1000. Whenever it's turning off, we're seeing LED low, delay 1000. Okay, and that whole process repeats over and over and over. Okay, so this is a very basic Arduino circuit. Okay, it's the first one that you're going to build, and once you finish it, you're going to go ahead and do something a little bit more advanced. Okay, by the way, to edit this code, what you can do is just copy it, go to Home, okay, click to create a sketch. You can see here it's a very basic set, and you can paste it in. From here you can click to verify that the code is good. You can make changes to it, say let's set the delay to 2000 that it's turned on, okay, and then run it on the Arduino. And so now I've run that code, and you can see it turns on for a longer period of time, and then it goes off for the same amount of time. So now it's delaying for 2 seconds instead of 1 after it turns on, and then still only waits for 1 second after turning off.